Okay, guys, so we're going to be working on Chapter 11 about depositing a continuous bead. Okay, so we really understand how stick welding works. We know that we complete a circuit and the heat from the arc melts our base metal and our filler metal, of course. But we know all of the factors that make a good weld and a bad weld. We know the arc length, right, is the diameter of our core electrode. And arc length, it affects how our weld is going to look at. So if we look at this, okay, we can see if it's too long or too short. Especially too short, it becomes very irregular. And if it's too long, we're also going to get a lot of spatter. Okay, same thing with travel speed. We know travel speed affects everything that we do. So we can see that it runs away if it's too fast. If it's too slow, it's going to be really, really wormy. Okay, and if it's too high, of course, it's just going to be really, really flat. Okay, we also need to look at the electrode angle, right? Whether it points away from direction of travel or towards. Okay, when we have a drag or a pull, it's going to be easier to have better penetration. Okay? And when we look, we can see that, oh, push, pull, drag. Okay? And when we have our first passes, especially when we're talking about T-joint and horizontal, we need about 45 degrees. Okay? But we also need to pay attention to our second and third passes. We want to make sure that we're not pointing too much down, because if we point too far down, we're just going to get it all on the bottom plate. Okay? All right, crater. Crater is pretty much the stuff that you cut out without putting any filler back in there. Okay? So if we have a crater, we need to wait for our material to fill up. If we don't, we can create a bunch of different issues. Okay? So if we have to restart, we want to strike in front of the crater, so it shows us to restart right here, and then come back and keep going. Okay? Takes a little bit of a practice so you don't leave too much of a lump. Undercut. This is it. Okay, so these are all defects that we can have in our weld. Undercut can be caused by many different things. Undercut is first caused by too much current, too much amperage. It's cutting into our material and not allowing us to fill it up. Okay? If we move too fast, we're moving too quickly for us to fill it up. And if we use an improper angle, and I'm going to even say manipulation, we're going to cut into our material and we're not going to be able to leave enough material. Okay? This usually happens a lot more often on a vertical plate. Okay? Overlap. I like to explain this by like a big tummy overlapping on the table. Okay? Usually this happens when it's too cold. Okay? And it's just going to sit on top. Remember we talked about it just kind of sitting on top of our material and not really burning in. If we look at this picture here, it's just sitting on top. There's nothing really happening with it, okay? So we need to make sure that we're actually paying attention to it, okay? The other thing that can happen with overlap is it's too hot and we're letting the puddle just do whatever it wants to do, and it's just going to sit on there. We're not preheating the base metal. We're not melting the base metal. Just the filler metal is running wherever it goes, okay? All right, arc flow. Arc flow can be a little bit difficult to understand, but ultimately, when we work with electricity, we also get magnetism, okay? And it affects everything that happens. So usually when we're using direct current, arc flow can be a little bit more, okay? But usually when we work on pieces less than 5 or 6 inches, we don't have to really worry about a lot of arc flow. It usually doesn't happen. Every once in a while it might, but we don't have anything to worry about. But should you, there are many different things that we can do, okay? The first one is switching to AC. Now, we all know that AC can't always be used for structure. So this is kind of a limited time offer. We can't always use that one, okay? Now, what else can we do? Well, we can always move our ground closer, okay? Moving your ground closer means that we can change the way the magnetic fields are happening on our plate, okay? The other thing is that also we can go, if we're going across the plate, we can go this way, and then we can call it and go the other direction is called backstepping, okay? We also can lower our current a little bit, and we can also make a shorter arc. Oh, all right, now, of course, we want to strike the weld with a chipping hammer. Okay, this is not a chicken hammer. We want to not strike it. We want to kind of move it across the weld to pull off the big chips. And then we're going to rub it with the wire brush to get anything off. Okay, the next video is going to be for our questions.